My name is Jenna Smith, and you're watching my summary of knowledge for biological anthropology. Like I said, my name's Jenna. I grew up on a small acreage close to Craven, Saskatchewan, but before I get into my personal life, I better disclose that I'm part of a clade. So let's start there. At human evolution. My oldest ancestors are all derived from a chimpanzee. And the package deal for primates like chimpanzees include prehensile feet, nails instead of claws, forward-facing eyes, large brains, single offspring, a long period of time for infant dependency, being diurnal, arboreal, social, and having non-specialized diets. And although the chimpanzee is my greatest common ancestor, human evolution happened over millions of years, and it took us a really long time to look this good. Through time, hominids began to walk on 2 feet, practicing bipedalism, which allowed for thermoregulation and energy efficiency. Also, bipedalism changed the way our heads were placed with the foramen magnum. In addition, the pelvis changed, and our spines shaped into S-shaped curvatures, and our feet, hand, and arms began to be proportional. With all the new ability, our brain became about 3 times larger than the greatest common ancestor, the chimpanzees. It's important to note that human evolution is mosaic evolution, which means that different body parts evolve at different times, and not everything happened all at once. That saying, humans are still evolving, because evolution is not stagnant. Going back to our hominid lineage, it gets broken down in taxonomy. Our kingdom is Animalia. Our phylum is Chordata. Our subphylum is Vertebrates. Our class is Mammalia. Order is Primates. Family is Hominid. And genus is Homo. With human evolution also began human immigration. As weather patterns began to shift throughout the landmass of Pangaea, people migrated out of Africa across the land bridge and into what we know today as North America. Alright, on this journey, we're now going to jump forward to 1881. I know that's a large jump, so let's go over a few things that happened between the beginning of civilization and 1881. A bubonic plague kills off 1/3 of Europe in the year of 1348. The plague spread because of infected fleas and other small infected animals like rats. Sidebar. Currently, 1 to 15% of all Europeans are immune to the HIV virus. One of the theories why is because of the plague. But the plague is bacterial, and the HIV virus is viral, so that one doesn't make a lot of sense. Moving forward, from 1400 onward, a bunch of sailors and explorers die from scurvy because of the absence of vitamin C in their diets, which can be observed in the skeletal remains, because scurvy presents itself as bone lesions. Anyway, speaking of sailing, in 1992, Christopher Columbus sailed the ocean blue, while the indigenous people, who had been residents in the soon-to-be, quote, New World, had been there for over 12,000 years, absent-mindedly started growing things like tomatoes, sweet potatoes, peppers, peanuts, and beans. And unfortunately, in the 1600s, European settlers began to exploit the New World for all it was worth in a capitalism lens. The interaction between settlers and First Nations people impacted culture, transmission of disease, and knowledge for both sides of the interaction. After the 7-Year War in 1763, a peace treaty was signed that would change the way that Aboriginal people lived in Canada forever. So, later on, I'll touch on residential schools. Okay, now that we got that covered, we're going to skip forward to 1881, just after the third pandemic in 1855. So in 1881, my great-great-grandparents, the Valgersons, immigrated from Iceland to Canada. Their push factor was that there was a huge volcano that was going to destroy their home if they didn't move. And their pull factor was that they wanted a better life for their 6 children. The Valgersons arrived in Manitoba, and that's where most of my immediate family is right now. Alright, so now I'm going to try and get into my personal life just a little bit more. I'm the daughter of Mrs. Smith and Mr. Smith. Using Mendel's laws, I made a Punnett square for my eye color. The square represents my phenome, or the genes that I inherited from both my mom and dad. However, the product is going to be my genome, or what is expressed in the gene. Through this process, you can see that I had a 50% chance of having brown eyes, 25% chance of having green eyes, and 25% chance of having blue eyes. Now, as you can see, my genome, or what was expressed, is green. So the 25% chance I had of having green eyes, I got. So my parents' genes make me me, but so do my stories. And when I was 4 years old, I broke my tibia, jumping out of a tree. But over time, my bone eventually remodeled itself using osteoblasts, or bone-creating cells, osteocytes, bone cells that maintain connective tissue in spongy and compact bone, and osteoclasts, bone cells that take unwanted materials away. Then, to ensure that the cells actually did their job, I broke the same bone twice more before the time I was 12. Because I broke the bone so many times, there would be signs of remodeling, which could be used to identify me, if that ever happened. That said, there'd be a lot of things that would be helpful if my skeletal remains were to ever show up and needed to be identified. The size and shape of my pelvis, the shape and size and arch of my zygomatic bone, and my long bones would all be helpful to give a clear identification. But knock on wood that I don't have to be identified by my skeletal remains. So when I was 4, I broke a bone for the first time, and when I was 6, I began to have a huge obsession with ancient Egypt. In that moment of time, I was pretty convinced that anyone could be turned into a mummy. But now, I know just how wrong I was about preserving bodies, as there are many factors that go into preservation. These include soil pH, because acidic soil preserves skin but destroys bone, which is less than ideal for a biological anthropologist, whereas basic soil preserves bone but destroys skin. Then, oxygen levels also affect the preservation of a body, as anaerobic or less oxygen, like the top of a mountain for example, increases the likelihood of mummification. Alongside oxygen levels, temperature plays a role in mummification as well. Permafrost, in particular, promotes mummification. Moisture levels also affect mummification. The more dry an area, the better chance one will find a mummy. In addition, if a body is fragmented, it is not good news for the preservation of the body. Meanwhile, if a body is complete, it is more likely to be preserved, like a mummy. Finally, if the body in question is the body of a subadult, they are more likely to be decomposed versus an adult, because the decomposition rate of a subadult is much higher, because the bone is less dense. Man alive, if I only knew that information as a child. Honestly, I'm kind of happy I was naive. But now, as a university student that takes advantage of carbs being the main primary source of fuel, I much prefer learning the dirty truth and the big picture. Like the sad and unfortunate truth about residential schools, how 150,000 Indigenous children attended, and how the last school closed in Saskatchewan, my home province, in 1996. Furthermore, there's a lot that anthropology teaches us, because the only way the world can move forward is by learning about what's behind us. And moreover, what makes us human isn't just bipedalism, reduced canines, and big brains, but also our ability to empathize, open our minds, and investigate the past as anthropologists do. My personal takeaway from this class is an expanded worldview and a better understanding of modern human behavior, as well as my own behavior, and how it is rooted in my primitive ancestors. I find it interesting that within the use of technology, because it is so new, in the past 100 years even, that humans are nowhere close to evolving for technology. Our bodies haven't even worked out the kinks since our ancestors began to walk upright. And overall, this class has given me a new appreciation for biological anthropologists and anthropology as a whole. But if I ever decide I wanted to become an anthropologist, there are so many subfields I could go into. These subfields include paleoanthropology, or looking at the fossil record for humankind, human biology, looking at human growth and development, skeletal biology, looking at human growth patterns and rates, paleopathology, looking at diseases in ancient human populations, like leprosy, or primatology, looking at non-human ancestry, genetics, and ecology. In conclusion, not only does biological anthropology teach us about ourselves, but also about where we came from.